Hi. Today I'm going to be talking about three sources of renewable energy. The first first form of energy I chose is solar energy. The benefits of this form of energy is that solar power systems drive clean, pure energy from the sun. Installing solar panels on homes help combat greenhouse gas emissions and reduce our collective dependence on fossil fuels. The negative aspects of this form of energy is that the technology needed to develop solar energy is extremely expensive. Manufacturing a solar panel requires expensive materials, and that solar radiation can only be efficiently absorbed during the daytime, because during the nighttime there's no sun out. The demand for the energy it generates is continuous, day and night. Other than these negative aspects, solar energy is one of the cleanest ways to obtain electricity. For the cost to use this sort of energy is that the system costs about, for just one of the normal average sizes, the 5 kilowatt system is ranging from $10,045 to $13,475, and this is after tax credits. A way to build and use this form of energy is that one would have to install solar panels onto the roof of their home. It has to be a place that would receive direct sunlight. The energy is currently being used all across the globe because, mainly in places where there's a lot of sun. So near the equator, not every place would be suitable, like the Antarctic where there's almost no sunlight at all. Solar thermal collectors are other means by converting sunlight into useful energy. Okay. The amount of energy produced, as of 2017, a typical solar panel produces around 265 watts of power. That can vary based on the size and efficiency of the solar panel you choose. Some produce 210, 280, or even 320 watts. This energy is transformed into the forms of energy we use by solar-powered photovoltaic PV panels, converting the sun's rays into electricity by exciting electrons in silicon cells using the photons of light from the sun. A diagram of this is shown here. Okay, to show you how a solar panel works, I'm gonna draw it out for you. So, we have a solar panel, right? There's the sunlight. Now the sun's rays are gonna go into this glass. Right, so this is sunlight, and the sun is absorbed onto a glass, and the energy of the light causes the electrons. So down here, there's gonna be electrons, right? And these are gonna be negative type electrons. Now, I'm going to represent these with a blue, so you know that these are the molecules. These molecules are going to go into the holes of the positive type charge. So down here, we have a positive type charge. And these have holes in them. Right? And these holes are moved by electrons, or the electrons move into the holes because negative goes into positive, and they need to match each other. And whenever the electrons move across, they excite an electric charge. So this right here, the movement of the negative electrons to the positive electrons, or positive energy, positive type charge, is going to create energy. This energy can be used for a multitude of things, such as powering your homes, just giving energy to, just powers everything, I guess. The charge is picked up by the metal constructs, which bring it to the battery. Alright, the next form of renewable energy that I chose is hydroelectric. The benefits of this is it only requires moving water to work, which is pretty good. It's considered to be a green source of energy. It doesn't pollute itself. It's a domestic source of energy. It's a renewable resource and is the most affordable cost of power when spread over the system's lifetime cost. It's reliable as long as there's water. Electricity can be generated. It is flexible. Water flow can be adjusted and even conserved for power. And it's safe. Compared to the other use of fossil fuels and nuclear energy, hydropower is a much safer system. The negative aspects of this form of energy, though, is that there's numerous environmental consequences of damming water. It floods entire area. It creates massive reservoirs. It changes the water flow. Sometimes that can be good or bad, depending on the situation. It blocks the natural course of rivers, and it constructs in constructing power lines and roads. There's only a limited number of places where these power plants can be built. Like, you can build it in the Sahara Desert. Their initial expense is huge, though comparatively, so are other resources. The lack of water, if there's a lack of water, droughts can have serious impact on how much hydropower can be produced. And fish can be caught in the flow of the water in the dam and be shredded by the turbine, so it can kill a lot of animals, and that's not good. The cost of using this form of energy is that it costs 85 cents per kilowatt hour to maintain a hydroelectric dam, and also there's a time cost and the initial cost. For example, the Etop Dam. It cost $20 billion and took 18 years to build, although the actual cost of hydropower dams are almost always far higher than the estimated cost. To build and use this form of energy, you'd have to have a hydroelectric dam, or you'd have to first build a dam, and you'd block off all the rivers and all the water, and then you install turbines that are connected to generators, and that's basically how you build it. It's hard, but it's simple in concept. The energy is currently being used anywhere where there's a river, and then that creates man-made lakes, and it's used all over the globe, or at least where there's rivers and where there's actually water you can use. So places like Africa wouldn't have a lot of hydroelectric dams, or places like Antarctica, because the water would just freeze in Antarctica, and in Africa there's just not a lot of water. The amount of energy produced is pretty enormous. It depends on the dam, though. So if you have a really big dam, it can create an enormous amount of energy. But if you have a small one, it still creates more energy compared to others. So modern hydro turbines can convert as much as 90% of the available energy into electricity. So that's a ton more than fossil fuels. Fossil fuels only create 50%. The energy is transformed into the form of energy we used by the movement of the water. It creates energy. The movement of the water creates energy, and that will then power the generators. And that energy from the flow of water creates electricity because the turbines. The turbines spin from the flow of water, and that energy is then created into electricity by the use of generators. And then I have a diagram to show you right over there. Okay, so I'm going to show you how a hydroelectric power plant would usually work. So right here, I have a flow of water from a river, and this river, flows into a hydroelectric dam, or just any power generator, and it looks like this, right? Now this water right here is diverted into a hydroelectric power plant. So let's say that the flow of water is then diverted from this flowing river into this room for a turbine. And it looks something like this, I guess. inside this room contains a turbine. Right? Let's say this is the turbine. And up here is the generator. Now, the water flows into here, and then it'll cause this to spin. Now, because this is spinning, it creates power onto this generator. And this generator then creates electricity. And this electricity goes up into a, what is it? One of these things, a transmission line to conduct electricity. So the transmission line looks like this. Right? Sorry, that's out of the way. So it looks like that. And then this will then bring electricity to homes. Now for the rest of the water that's just stuck in here, the water is then going to go through this opening back into the river. The river's going this way. And it'll flow into the river and then just go back in its normal route. And that's basically how it all works. Alright, the last renewable resource I chose was wind energy. And there's many benefits from this form of energy. The wind energy is a green energy source and does not cause pollution. The potential of wind energy is enormous. It's 20 times more than what the entire human population needs. The wind power is renewable, and there's no way we can run out of it, since wind originates from the sun. Wind turbines are incredibly space efficient. The largest of them generate enough electricity to power 600 US homes. The prices have decreased for over 80% since 1980 and are expected to keep decreasing. The operational costs associated with wind power are low, and there's good domestic potential. Residential wind turbines yield energy savings and protect homeowners from power outages. But there's also negative aspects from this form of energy, that wind is fluctuating. The source of energy is not suitable to meet the base load energy demand unless some form of energy storage is utilized, like batteries or pumped hydro. The manufacturing and installation of wind turbines require heavy upfront investments, both in commercial and residential applications. Wind turbines can be a threat to wildlife, such as like birds, bats, insects. They can get hit by the turbines and die or get seriously injured. The noise is regularly reported as a problem by neighboring homes. They don't like it. And how wind turbines look, the aesthetics is actually a concern for people, which I don't get. The cost to install or use this form of energy is around $48,000 to $65,000 to install a 10 kilowatt wind turbine, and the equipment cost is about $40,000. The rest of it is shipping and installation. To build and use this form of energy, you have to ask a professional, honestly. There's many do-it-yourself videos online that can show you how to make one. First, you have to download the measurements, but then you can make the blades and connect that to a generator, which will be able to power the generator if it's able to spin, and if there's enough wind in your area. This energy is currently being used anywhere where there's a lot of wind, which is all across the earth. The best place to put it, though, is in a large open field where the wind is strong. Just basically anywhere that actually has wind and is strong enough to power a wind turbine consistently. The average amount of energy produced, an average wind turbine, is able to produce 2.5 to 3 megawatts and can produce more than 6 million kilowatts in a year, enough to supply 1,500 average European households with electricity. And the energy is transformed into the form of energy we use by, it's very similar to how hydroelectric dams work. The wind turns the blades, like how the water turns the turbines in the hydroelectric in the river. The wind turns the blades, which spin a shaft, which connect to a generator. It makes electricity, and the wind turbines convert the kinetic energy from the wind into mechanical power. And I'll show you all that in my other diagram that I have on my whiteboard. And it's my last one. Okay, so here's basically how it all happens. So you have a inflow of wind, right? In a windy field. And you just have some wind turbines right here. And right here is a better wind turbine. So I can show you how it all works. So this wind turbine, and the wind blows into the turbine, and this causes the blades to spin. Now inside the turbine, there's a generator. This generator creates electricity by the kinetic energy of the spinning turbine. This energy is then able to be transported into an electricity tower. This goes into an electricity tower. Hopefully you can see that one this time. And then this tower then is converted into electricity for your home. Now I forgot one step. There's a transformer which increases the voltage to send to the electricity tower along the way, and that's right here. And that's pretty much all there is to it. Hope you enjoyed, and I guess that's it.